Hello, my name is Marlon Peugeot. I'm in the tour. I'm actually the guy at the back of the line here. And this is a very complete plant tour. This was the entire site in Pasco, Washington when the plant was running full time. The first thing we're going to come over to is look at what we call the feedstock. This is the fluff. This is what all the MSW, municipal solid waste, the plastics, the food, and everything was turned into what's called fluff. And this is a known process. People do what's called RDF, refuse derived fuel, where they turn trash into something that can be burned or whatever. In our case, we don't burn it. We make this fluff through a whole process of machines. The trash is brought to the landfill. We're hopefully going to locate at the landfill. We have shredders, and we cut up all the feedstock, plastics, everything are mixed together. We then have magnets, and what the magnets will do is they'll take any steel out of the feedstock that goes in, or the trash that comes into the landfill. The minimum we get is about 120 gallons per metric ton. If it's plastics, we get more. The next thing we're going to do is, again, we're at this site, and you can see some piping overhead above me. We're going to come around to this side unit here, and this is what we call a nitrogen unit. For safety purposes, we run at atmospheric pressure in our reactor, but one of the things we do is we do it under a nitrogen lock. By there not being any oxygen or anything in the reactor, this allows for safety. You cannot have explosions or combustions without any oxygen. Again, we're not a combustion unit. We do not burn. We're not an incineration unit of any kind. Now, all a nitrogen unit is this is a unit that literally, and we'll try to give you a sound bite on this one, it literally pulls the air. 78% of the air is nitrogen. So it literally pulls and condenses the nitrogen simply by pulling in air. And you'll see the storage tank there, and that is piped over to the reactor. When we go outside to the plant, you'll see the rest of the plant. The 21% of the air that we breathe is oxygen. This is what we survive on. Probably about 1% of it is carbon dioxide. So again, this is a nitrogen unit intended for ultimate safety. We want our plant to be safe and not have any possibilities of problems. On the left here, you see a large tank. This is gives an idea of the storage tank for the fuel. This is an extra tank. You'll see the tanks as we come walking outside. We're now going to come walking out to the plant. The first thing you see on the left as we come out to the plant here, we're still stopping here for a minute. We're going to go out to the plant. This is just more fluff in the boxes. We had the process off-site. That whole front-end process will be with the plant, but because we were in a port and they didn't allow us to bring the raw material in, the fluff was just created off-site. Again, there's no integration required. The fluff would then feed into the entry bin at the plant here. We're coming out to the plant. The first thing we pass is the tank basin. And all the storage tanks, the fuel and everything are in those basins we just passed on the left. This is a photo op. This was a group from Senegal. There are both ministers, the Minister of Finance, Education, as well as the technical people are here. A couple of the people in this group actually run a refinery in Senegal, so they have experience in petroleum. As you can see, the plant is not huge. You're looking at the plant on the left hand. We're walking past the plant right now. We're going to go to you can start to see offices here. They're integrated into the plant. All the building and structure is included in the plant, so it has fuel labs, all the different buildings. The first location we're going to go into is down here at our lower level. And this is where we have our switch gear. Because our plant is designed to be built in third world countries where they don't have consistent electric supply, one of our byproducts from the distillation tower is natural gas. So we take that natural gas, We go to a turbine and we produce electricity. We produce 2.5 megawatts of electricity, in excess 1 megawatt that we can send back to the grid. So if you had a power generation unit at your house, this is the switchgear that allows you to either run off of the grid, be powered into the city, or to produce your own power and send it to the city and sell your electricity to the power grid for the local municipality. So again, this is very large industrial electrical switchgear. And you can see this keeps us running 24 hours a day, 365 days a year. Again, we are not dependent in any way on the local grid. We're now going to come around to the feedstock area. And the feedstock area here is where we're going to put the feedstock into the bin. Now this feedstock would normally again be processed, and the trash would come in and be converted to the fluff that's going to go into the system. You also see two large white containers elevated there, a round cylinder. That's our catalyst. Our catalyst is only 1%, and the other tank there is for lime. So the only other things besides the trash that go into our process is the catalyst and lime. The catalyst is 1%, the lime is 0.3%, or 1/3%. Again, at this site, we put the fluff in with those bins you saw in the first warehouse. Here the forklift is going to put it up on that second level, and then simply we flip it into the major bin. Now that major bin, it will still be the first component in the physical plant, and that will be fed by the feedstock that, instead of coming from these containers, would simply come from the front end processing area and just be piped directly into this container. This large container is very simple. It's just a container. You'll see them climbing the ladder, and what they're doing is they're looking inside the container to make sure that we really are putting fluff into the system. The container simply has a mixing arm, and the only reason for this mixing arm is to mix the catalyst and the lime in, but also to keep the feedstock from clumping up, literally getting into clumps and being clumped together as opposed to being separated like confetti. You're also going to see a clear pipe here coming up as we turn this corner. We use basically sprinkler piping system, but that clear pipe is so that you can see the fluff in a pipe. Now we're looking into where the armature is. Again, it's a simple motor, and all it is mixing the fluff with the catalyst and stuff. Again, they're here to see that all the devices and everything are doing what we say they're doing. We're now walking up the ladder. We're going to go up a set of steps here, and again, these offices are built in and integrated into the system. The first office we're going to walk into is actually the fuel testing lab. When you sell fuel into the fuel stream in any community or anywhere in the world, you continually test the fuel. Every batch or every 100 or so gallons, you'll take a sample and you'll test the integrity of the fuel. You're looking at your cetane level, your sulfur levels, your moisture levels, and such. This little closet here is where you can have small pipes that come from the plant itself, and the samples can be grabbed there, or the samples can be taken later when you see where the fuel is pumped from. So again, this is going to be your fuel laboratory. It's obviously vacant now, but it would have beakers and machines and everything to give you the actual output to do proper fuel evaluation and testing. We're going to go up another short level here. The next level is another building, another office, and this next level would be the administrative offices. And this is where you might have a few staff people who are keeping track of the trucks and the tonnages of the trash that come in. scheduling the fuel trucks that'll be taking the finished diesel directly to the filling stations. And again, we do finished fuel. We make real diesel. It's real mineral oil diesel, the same as you would get from fossil fuels or petroleum-based system. It's a mineral oil diesel. Notice we're walking on top of the plant at this point. And again, the plant is very walkable. A lot of safety rails. There is no danger. We're not wearing hard hats. This first simple device we're coming up to is just a standard cooling tower that we buy from a company in Baltimore. So again, not anything fancy or unique. We're going to put the camera up and you'll see a clear pipe he's going to zoom in. That's the Fluff again. So that same Fluff you saw in the bin is now going overhead and being brought over to the reactor. Also, when you look up, you'll see these yellow I-beams. These are what we call service I-beams, where a gantry crane can be hooked onto that I-beam to, say, service the motor in the cooling tower, service the vents in the cooling tower, or whatever else. So again, this is a very service-oriented plant. We actually have a storage unit on site that would have seconds. These are spare motors for the cooling tower, spare pumping motors for the fuel. You'll see there's not a lot of moving parts in the plant, but all critical parts would have a replacement. As soon as the replacement is used, parts are replaced, brought back in, so that the storage unit is always current. This is an issue you have a lot in third world countries where they sell people things, but they don't sell the spare parts. Our spare parts are on site because this plant, once we eliminate landfills, the plant has to be online all the time. We're now going to proceed over to the top of the reactor. You can see that green washdown shower. You've seen a few of those on the plant. Again, we were built to U.S. safety standards. If anybody were to get any kind of oil or material on them, that shower would give them an immediate rinse off for protection. But again, very, very safe. We're now at the top of the reactor. And this is very simply, again, the reactor runs in a liquid-based, liquid pyrolysis process. And all we do is we feed into the top here through those same pipes that you saw. And we feed the catalyst, the Fluff, which is all of your municipal solid waste, plastics, bottles, wood, everything together goes in. This is where the reaction occurs. In this reactor, we create a vapor. We simply go at temperatures around 300 degrees Celsius, and we create literally a carbon vapor, which is what comes and goes into a standard distillation tower. So the pyrolysis oil goes out, and then heat is put to it, and we go to a standard planar distillation tower. So we produce kerosene, heating oil, diesel. All of this process is pushed up through this distillation tower, and the different weights of the oils are removed at the different levels. If we want to make jet fuel or gasoline, we can build a taller distillation tower, put more heat to it, and you get different levels, different quantities of fuel, and you use more energy to produce it. What we're looking at now is some of the loop piping that is done on a distillation tower, and this again is standard planar distillation tower. Just a series of angled plates, and the vapors will condense at different levels in the tower depending on the fuel that we're shooting for. So by setting the temperature at the base of the distillation tower, if we prefer to have 95% of our output to be diesel, we do what's called, or we select what's called a diesel cut from the system. We're now going to go ahead and go back down to the ground floor. And again, you'll see there's additional ladders so that service people can climb all the way to the top of the distillation tower and do any type of work that may be necessary. We're now going to go down to the lower level. And believe it or not, when we get to this lower level, we're going to go into what's called a control room. And in this control room, you'll see all the electronics, all the relays and that operate with all the thermocouples and all the sensors and everything for all the electronics that run the plant. We run on a SCADA system. We use modern artificial intelligence in our operating models. So again, very modern controls, modern systems. So we're going to go into the electronics. So you kind of see we're leaving the industrial phase. We are an industrial process, but we're leaving the industrial part of the process and going to the control system. And again, you can see all the piping is very neatly done here. Everything was built to a U.S. standard. All the raceways are very neatly done, as you can see the pipes to the right of us here. All the flutes, everything is color coordinated and painted on all the devices that you see. The control room area that we're going to go into, where you can monitor all the temperatures and pressures of the system and actually control the flow of the process. The time in the reactor from the time the fluff is converted to the vapor, the carbon vapor for distillate, is 21 to 48 seconds. So again, we're not a slow process. It's a continuous, fast industrial process. What you see here is these are all the alarms and safety relays and all the interlocks that come into all the thermocouples. So these all tie into the controls. And then, like I say, from the computer screen, he can get all the readings and know all the pressures and temperatures of the system. You'll see right here is that the operators there, they're taking pictures of the computer screen, which has the SCADA system diagrammed on it, as you would see in any other computer-operated process, commercial or industrial process. Again, very modern controls and relays. Everything is built to current standards. You can see all the exit lights and fire extinguishers. Everything is safety oriented here. That device you see there is the turbine. And that large unit there, that right there, takes the natural gas off of it. It was on the left, now it's on the right. The only heat source in the plant and the heat that operates both the distillation tower and the reactor is these 8 electric heaters off to your right. The electric heaters are powered by the turbine that again gets its power from the natural gas that comes off the distillation tower. When you start a plant for the first time, you can do the same process or put diesel fuel into the same turbine. So the turbine is actually a mixed fuel turbine that allows for diesel or natural gas to be burned to produce the electricity for the plant. So now we're going to move down from the electric heaters and we're going to start walking over to where the fuel distribution center is, as we're coming back towards the fuel storage tanks that we passed on the way out. So we're walking down through the plant, so we're going to go past the reactor again, past the distillation tower as we come in here on the right. The dumpster you see here, the only solids that come out of our process through a centrifugal purge is the spent catalyst and any silicates that may be in there. They go into this dumpster. It's only about 10%, so if we process 100 tons, you would have 10 tons of it's a solid waste that can be used in the asphalt or the concrete industry. We're now at the fuel distribution center. You'll look down and see those 5 motors. One motor pumps kerosene, one pumps diesel, one pumps fuel oil, one pumps the solids that may go back to a reboiler. And what he's doing now is simply filling a beaker up with finished diesel that was produced from the feedstock that we're putting in. So as you can see, the process happens in minutes. He's also going to go to one of the smaller taps and take a kerosene sample, It's going to be a darker liquid because the kerosene usually goes through a filtering system. But the finished diesel, you can look at the quality of the fuel in the beaker. Looks just like the diesel you buy at the station, although it's of better quality. We're a higher cetane, 56. Normal fuel is 48 cetane that you get at your filling station. We are also 2.4 parts per million sulfur. Lowest sulfur rating, ultra low sulfur rating is 15 parts or less. We're well below that. So again, a cleaner fuel than what you would normally get at a filling station. We're also going to take a larger sample in a gas can, and this is because these people wanted to take the fuel themselves and have it tested separately, independently of what we do with our fuel testing. So again, he's putting some of it in a truck. We run all the vehicles on site. When the plant's operating, the fuel was given to local farmers as there's a grape and apple industry in the area. The regulations for putting the fuel in a road scenario is you need to obviously create certifications and everything going forward, which we can do. Our fuel can be fully certified and it meets all the ASTM standards. And if you go on this same website, you'll see that under the Waste to Energy CDP part of the site. So again, we have now made fuel from the fluff that you saw us put in, and now we're going to walk over to an area where we have a burner set up so we can burn the fuel. We'll also do what's called a burn test, where you put the fuel on a paper towel, literally light it with a match, and show that it is combustion. If you were to take biodiesel, for instance, you wouldn't be able to start it on fire without mixing it with methanol. So again, we are true diesel, we're not biodiesel. As you can see, there's that tank. That just shows you how easy the manufacturing. We are a simple steel manufactured plant. It's very simple steel construction. There isn't anything fancy. As you can see, the diesel is on a piece of paper towel and we're burning it there. The black smoke you see is basically because the paper itself is burning. The diesel itself burns clean. He's also going to take that beaker. You see him putting a hose into it. He's going to hook that up to that oil burner, that cylinder that you're going to see coming into the view. And that will start up. I'm going to be quiet here so you can hear it start. And we are now burning fuel in that tank there with a simple oil burner. Simple hose is pulling from that beaker that he just filled with the fuel. You can see these gentlemen are putting their hand over top of it. They're going to take their phones and try to take some pictures of it. We'll bring our camera around here eventually and show you that same flame there. The other thing he's going to be doing here shortly is he'll be turning the air shutter off on the oil burner and trying to cause